Hi students, let us discuss banking of rod at sharp turns generally seen on highways. If you notice at the at the curved path, we generally notice that outer edge of the rod is slightly lifted with respect to inner core of rod. Why it is taken to be like this? Why it is made a little lifted from outside? There is a science behind it. For the safe turning, as we know, in case of a bike can be leaned from the vertical for turning purpose. But if we talk about four-wheelers like car, truck, then they cannot lean at one side because they run on four wheels. So it is not possible for everybody to lift two tires from the ground, and it leans on just two wires of the and it leans at the two wheels at a side. At least I cannot do this because I am a very bad driver. Then see how it is important, what are the conditions due to which we have lifted outer edge of the rod. Just come to an event in which a car is turning at the curvature of a rod. Say there is a car which is moving with velocity v on this curved track. The forces that may act on this car will be, the first thing, force of gravity, which is equal to mass into acceleration of gravity. The other force which is acting on this car is the normal reaction acting on this, denoted by R here. If this is the center of curvature of rod, then obviously this distance from the center of curvature to the path of the car, say it is R. Say it is R. If we take reference frame at car itself, taking origin at the center of gravity of the car, obviously as car is turning on a circular track, the reference frame chosen by us will be a non-inertial reference frame with acceleration v square by r. It is the radial acceleration. So, with respect to the chosen reference frame, there will be one pseudo force acting on the car. And this pseudo force can be taken here away from the center of circular path, obviously in this direction, and this centrifugal means pseudo force will be mv square by r, the radius of the circular track. Say this angle is theta. No doubt, this angle will also be equal to theta, because this is theta, so this is 90 minus theta, and this line is perpendicular to this line, so the angle between mg and normal to the inclined plane, this angle will also be theta. If this is theta, then this is also theta. Now see, what can we do here? I am considering it in two manners. First method, it involves, in which I will do component of all the forces acting on this car, and finally by equating the opposite components I can get two relations here. If I talk about x direction, then obviously there will be one component of this reaction r along horizontal direction, which can be taken as r sine theta, and this is compensated by mv square by r. So along x direction I may write r sine theta is equal to mv square upon r. And if I talk along the y direction, then I can write r cos theta component of normal reaction r is compensated by mg. For the self-turning, net force on this car in this mode must be 0. That's why I have taken x and y components and I have equated the x component of forces r sine theta along positive x and mv square by r along negative x. In y direction, r cos theta upward and mg is downward. Now I can write r sine theta divided by r cos theta to be equal to mv square by r divided by mg, which yields tan theta is equal to v square by rg. So angle of banking for the rod, it must satisfy this equation such that if theta is banking angle, then tan theta must be equal to v square upon rg. Under this condition, car will take self-turn. If we know the banking angle and radius of curvature of the path, then by using this formula into this form, v equal to under root of rg tan theta. So this is the velocity which we see on the sides of highway, where at some turns a speed limit is shown, because that speed limit is the velocity obtained by this equation, where r is radius of curvature of the path, g is acceleration due to gravity, and theta is the angle of banking. Though the same result, this method involves use of Lami's theorem. So I can write it in this way: r upon sine 90 degree equal to mg upon sine 90 plus theta equal to mv square upon r sine 180 minus theta. So by using this relation which I have written using Lami's theorem, I can also get the same result which is obtained here as tan theta equal to v square by rg. Now if the outer edge of the rod is lifted by height h and width of the rod measured along the rod it is b, then tan theta is equal to h upon under root of b square minus h square. So h upon under root b square minus h square, it becomes v square by rg. So by using trigonometry, tan theta can be written as perpendicular upon base, and base can be written here as b square minus h square under root. So by putting value of tan theta from here to the equation which we had attained by the two different processes, so h upon under root b square minus h square, it is equal to v square by rg, or b square upon h square can be written as 1 plus r square g square upon v to the power 4. Finally, solving it, we get h equal to under root of b square divided by 1 plus r square g square divided by v4. By this equation, the height of the outer edge with respect to the inner edge can be calculated, that for a particular speed, what must be the height of outer edge with respect to inner edge. I think you got what I wanted to show you by this analysis. So friends, again happy learning. Keep on watching my video lectures on Mega Vidya.